Hello and welcome back to Math Class in Session. Grade 11 Math. This is where we put the fractional exponents on the base. Rational exponents we call them. To do this thing, simplifying expressions that involve exponents, we are going to have to know that we take the cth root of a to the b when we see this expression. We're also going to have to know all the other root laws for exponents, like when you multiply powers of the same base, you keep the base and you add the exponents. Yes, we'll have to know that. We'll have to know how to add and subtract fractions, of course, but certainly we'll have to see, when we see this, we'll have to think cth root of a raised to the exponent b. Remember, this would be the square root of 9 raised to the exponent 3, for example. Like that. Now this 2 doesn't have to be written, but I just wrote it just to show you, but if you didn't write it in an index, the understood index would be 2. And so this would be root 9 cubed. And of course root 9 is the number 3, and 3 cubed is 27. Now let's plunge into some examples of simplifying expressions. Here we go. That's an expression, and we like it simplified. Now just as there's more than one way to get from A to B in a city, you could take different streets to get from A to B. We can take different routes to get from that expression you see in front of you and the simplified version, which is going to come in a couple of minutes. Let's take a look at this. My intention is to, well, let's just see. Execute inside of these large brackets, which means this entire part of the contents of this bracket is going to have a -2 exponent applied to it. And the only reason that's true is because the operation in here is multiply. If it was add or subtract, the story would not be true. But since it's multiplied 32 times x to the 5th, I can apply that -2 to both of those factors. And we get 32 to the -2 and x to the -10, because in that configuration you multiply. And this will be x to the -10 as well, because in this configuration you multiply. That's why this says x to the -10. And 0.2 is 2/10. So we've taken a big step towards simplifying. Now take a look at this. These are factors that match. So a factor of the numerator and a factor of the denominator that match. So we're allowed to do this. They cancel off. Then the negative sign here puts this 32 on the bottom. So it's 32 squared on the bottom, and 2/10 reduces to 1/5. Now we have to take 1 over 32 squared to the 1/5. Well, if we apply the 1/5 to the top, we get 1 to the 1/5, and of course 1 to the anything at all is 1. 1 to the 0 is 1. 1 to the 1/5 is 1. So I've applied 1/5 to the 1, and I'm applying 1/5 to the 32 squared. And in this configuration, I multiplied the exponents. 2 times a fifth is 2/5. Now remember what I said at the beginning of this. This is going to tell me the 5th root of 32 squared on the bottom. Because that's how a rational exponent is handled. Now the 5th root of 32 is a number that we know it's 2. Because 2 times itself 5 times gives me 32. You can try it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 2's all multiplied together. So we get this. And here's our simplified version. Math people consider this simple compared to this, but they're the same. And that's what this area of math is about. It's a tough area. There's no question about it. This is a hard area. Even if you don't understand this totally, there's nothing to worry about. This will sink in over time. This part of the course is, yeah, it's hard, it's weird, strange. Your job is to try and to see if you can get some of the answers right. Let's do another example. Here we have a big root sign, and inside that root sign we have a big fraction. And in the numerator of that fraction we've got a complicated expression, and we want to simplify it. Now, if we go back a ways here, remember this? A fraction here makes a root sign happen, and it works the other way too. If you see a root sign happening, we could turn that back the other way and call it a fraction. So remember that. A fractional exponent makes a root sign, while a root sign makes a fractional exponent. So let's go back to where we were. And here we are. We got this root sign, and that's going to make a big fractional exponent. The understood index is 2, so this is a 1/2 exponent. Let's take a look at it. There it is, a 1/2 exponent on this entire giant fraction in here. So that's all I've done, is I turned a root sign into a fraction. I'll need these brackets, of course. Now, inside the brackets, I can see that this 1/2 exponent is applied to the 25, and it's applied to the x. And so it'll be 25 to the 1/2, but we do that in our head. 25 to the 1/2 is the square root of 25, so that'll be 5x to the half in the numerator. And this is 8 to the 1/3. 8 to the 1/3, remember, we'll take the third root of 8 to the 1. Third root of 8 is 2, because 2 times 2 times 2 is 8. And this will be 2 times x to the 2/3 in this numerator. Let's check. Yes, it's 2 times x to the 2/3, while this is 5 times x to the 1/2. You can always pause these videos and dwell on what I just did there. See if you agree. See if you can see why it's right. Now, a pretty big thing happens, because this is 5 times x to the 1/2 times 2 times x to the 2/3. This is all times. So order of multiply doesn't matter. I could put those x's beside each other if I wanted to and call it x to the 1/2 plus 2/3. Because when you multiply powers at the same base, you keep the base and add the exponents. So I could add those exponents. And similarly down here, I'm dividing by a power of x as well. And when you divide powers of the same base, you keep the base and subtract the exponent. So this is going to be x to the 1/2 plus 2/3 minus 1/6. Well, on the numerator, we'll have 5 times 2, which is 10. That's why we have 10 times x to the 1/2 plus 2/3 minus 1/6. Still over 40, but I've handled that x because I divided the powers. And now we can simplify this. Now remember, you have to know how to add and subtract fractions. Those are fractions. We need to add and subtract with a common denominator. And we get 6 over 6. So add these up. This is 3/6 plus 4/6, that's 7/6, minus a 6, that's 6/6. So that's just x to the 1 in there. That 1/2 is that 1/2. And 10 over 40 reduces to 1 over 4. The 1 factor is invisible. So now we have this expression, and we take the square root of the top over the square root of the bottom. So it will be root x over the square root of 4, which we know is the number 2. And here's the simplified version. And I grant you, a person has to be good at a lot of skills to get from this to this. You have to know about laws for exponents. You have to know about fractions. You have to know about factors. You have to know about a lot of things. So that's why it was necessary to do your homework, to work away at it, and not worry too much if this particular area of math has got your goat. Let's move on. Your reflexive knowledge. If a person learns their times tables, they know that 9 times 7 is 63 without having to think about it. They know that 6 times 8 is 48. They don't have to think. It's a reflex. I would suggest that you add to your reflexive knowledge. You should know some things, like the squares. You should know your squares. So 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. Know them all the way up to 15 squared is 225. You shouldn't have to pick up a calculator to know that, say, 13 squared is 169. This is going to help because if you see the square root of, say, 225, you'll go, right, 15. Square root of 16, right, it's 4. Learn some cubes. 2 cubed is 8. You shouldn't be counting on your fingers. 2 times 2 times 2 is 8. 2 cubed is 8. If you just learned that, it would be good for you. 3 cubed is 27. 4 cubed is 64. So you see this number 64, it's 4 times 4 times 4. It's also 8 times 8. It's also 2 to the exponent 6. Some fourth powers? Well, okay, I forgot this one. 5 cubed is 125. 5 times 5 is 25, and 25 times 5 is 125. But if you could just see this number, 125 here, you could know that that's 5 cubed, and it would help, because one day you'll be asked, what's the cube root of 125? And you don't want to be reaching for your calculator all the time. You just say, what's the cube root of 125? It's 5, because 5 cubed is 125. This should be added to your reflexive knowledge. Fourth powers? Okay, I forgot. 6 cubed, 216. Okay, all right. Learn that one too. Fourth powers? 3 to the fourth is 81. 3 times 3 times 3 times 3 is 81. Notice fourth powers are really squares, because this is 3 squared squared. 3 squared is 9, and 9 times 9 is 81. So this is 3 squared squared. All the fourth powers are like that. So the next one will say 4 to the 4, so that'll be 4 squared squared. So it'll be 16 squared. And 16 squared is 256. The next one will be 5 squared squared. The 25 squared, which is 625. Fifth powers, this is good to know. This comes up a lot. 2 to the fifth is 32. You just have to learn that like you did your times tables. Somehow you just have to get 2 to the fifth is 32 and remember it reflexively, the way you learned your times tables. It would help a lot. Moving on to one last example here. One last example. We have to take this and go across here to what the answer is. And you know that it's going to take some doing, and there's more than one way to do it. We could definitely do it a couple of different ways. We could call this, see this x to the 1/2? We could call that root x, and then cancel these two right away. That works. Or, you see these two radicals here? Well, we could take x cubed divided by x to the 1 and call that x squared, because that's true too. And so I divided under the radical signs to get this. And then this radical sign makes a fraction. So there's a root sign right here, and it makes a fraction. It's 2 over 2, which is, of course, 1. So this is just x, really. Now it's still underneath this root sign, and it's still times x to the 1/2. Multiply powers of the same base, keep the base, and add the exponents, and it looks like this now. Now we have to square this. Well, how are we going to do that? Okay, I turned this radical sign into a set of brackets with a 1/5 on it. The set of brackets right here with a 1/5 on it. That's what this root sign is. A root sign makes a fraction, and there it is. And now, inside the big brackets, we get multiplying exponents in this configuration will be 3 over 10. And multiplying those exponents will be 6 over 10. And 6 over 10 is 3 over 5. And 3 over 5 is the 5th root of x cubed, because you learned that law for exponents, the one where it says fractional exponents. And if you don't end up there, don't be too hard on yourself. It's a hard area of math. It takes a while of sinking in and trying these things and dwelling on them and trying them again. And just put some effort into it and don't worry about it.